I'm going to take a brief look in this video at independent and mutually exclusive events. So there's two formulae that are relevant here. The first one here is for mutually exclusive events. Okay, which means that one event cannot occur at the same time as the other. There is no intersection. This one is for independent events, which means that the probability of one event occurring has no bearing on the probability of the other event occurring. So we're going to look at two examples, one of each. The first one says the probability of rain on a given day is 0.3. Find the probability of randomly choosing a king from a standard deck of cards on a given rainy day. So we have two events, raining and choosing a king from a standard deck of cards. These are independent, which means the fact that it rains has no effect on choosing a king. The fact that we choose a king has no effect on the fact that it's going to be a rainy day. So if we want the probability of both occurring, then we're looking at the probability of rain and choosing a king, and we simply multiply the two events together. Probability of rain that we were given was 0.3, and the probability of choosing a king from a standard deck of cards is 1 out of 13. Okay, there are 4 kings in a pack of 52. That simplifies to 1 over 13. So that's 3 over 130. This second example looks at two events, C and D, which are mutually exclusive. What that means is that the probability of C or D is equal to the probability of C plus the probability of D. This is the formula for combined events. It's just that in mutually exclusive events, this probability is 0, and so we don't bother including it in the formula. So the probability of the intersection is 3 over 14, the probability of C is 1/7, and we have to find the probability of D. So all we're going to do for that is subtract 1/7 from 3/14, and that should give us 1/14.